All right, so in this video, we are going to define the unit circle and its many parts. The unit circle is just a circle with a radius of 1 that's centered at the origin. So basically, it's this really tiny circle, but we can scale it out and it can be applied to all sorts of real-life applications in engineering, architecture, plenty of examples like that. So we're going to look at the base example of the unit circle. We're going to use sine, cosine, and tangent to help us solve some of these problems as well. So let's jump right into the examples. So this first one, we are evaluating the following angles, all located in the first quadrant. So let's do a quick sketch of the angle of 30 degrees. It looks something like this. And we're going to go ahead and make a reference triangle, which means we're going to draw a line straight down from where that angle intersects the circle, make an altitude, so we have a right angle at the x-axis. And we can do this because 30 degrees, of course, is its own reference angle. And then, of course, this top angle would be 60, since there's 180 degrees in a triangle. So now let's go about labeling the parts of this right triangle. The hypotenuse is going to be 1 unit long, because this is the unit circle, and the radius of the unit circle, which is the hypotenuse we established, is 1 unit long. And then we're going to use our patterns of special right triangles to help us get these other lengths. The shortest side is always 1/2 the length of the hypotenuse. So that means this vertical side over here is 1/2. And then the horizontal side, down here across the bottom, is just the shortest side multiplied by radical 3. And if you take 1/2 and multiply it by radical 3, you may have already memorized this answer. You get radical 3 over 2. If you haven't watched the special right triangle section, you'll want to watch that before you work on these. So to actually get the sine of 30 degrees, we have to think back, okay, sine is opposite over hypotenuse. And from 30 degrees, the opposite side from 30 degrees is 1/2. Of course, our hypotenuse is just 1. And anything divided by 1 is itself. So the sine of 30 degrees ends up being 1/2. Again, sine of 30 just represents the ratio of the sides at 30 degrees. The cosine of 30, so you can think back cosine. Cosine is a over h. The adjacent side of 30 degrees is radical 3 over 2, divided by the hypotenuse, which is still 1. And anything divided by 1 is itself. So sine and cosine work out nicely there. And one thing I want you to see that we haven't mentioned yet, radical 3 over 2 is the horizontal length of that triangle. So that means it represents the x-coordinate of where this angle intersects the circle, because x goes left and right. 1/2 represents the y-coordinate, since it's the vertical distance. So you can kind of start seeing how x and y relate to sine and cosine. All right, and then finally tangent. Tangent is O over A, or in this case, 1/2 divided by radical 3 over 2. And then we're just going to multiply by the reciprocal of radical 3 over 2. Anytime you divide a fraction by a fraction, you multiply by the reciprocal. So multiply the tops, multiply the bottoms, the 2's cancel out. You have to rationalize the denominator by multiplying bottom and top by radical 3. Tangent is always going to be more work than sine or cosine. There's our answer for tangent. All right, let's do one more together. Let's do pi over 4, which is still in the first quadrant. Again, we kind of start it the same way. We sketch the angle. We make the radius a length of 1. Keep in mind the horizontal side, we're going to start calling it x. The vertical side, we're going to start consistently calling it y. Remember the pattern for 45, 45, 90, because pi over 4 is the same thing as 45 degrees, is 1, 1, radical 2. So that means to get these two short sides, we have to take the hypotenuse and divide it by the square root of 2. Rationalize the denominator, and we end up with radical 2 over 2, and radical 2 over 2. So then let's do sine. Sine is over h, or you could say y over r, same thing. The y coordinate is radical 2 over 2. The good thing is the radius for the unit circle is always 1. So sine ends up being the same value as y. And likewise, cosine is a over h, or we could write it as x over r, but it's still going to be the same. It's radical 2 over 2 divided by 1. We want to see that relationship between cosine and x and sine and y. And then finally, tangent. Tangent's over a. Think about the other way to write tangent using y and x. The opposite side is y, the adjacent side is x. So a formula we can use for tangent is the y coordinate divided by the x coordinate. In this case, since the y coordinate is radical 2 over 2, and the x coordinate is radical 2 over 2, we don't have to go through the same process we did on the previous problem, because anything divided by itself is 1. I would encourage you to pause the video and try to do this last example on your own. That's how you should start it, and use special right triangles to find those two missing sides. And one thing you'll notice is the x and y for 60 degrees is just reverse of the x and the y that we got up here at 30 degrees. So the sine of 60 is the same thing as y divided by r, and since r is 1, sine is the same thing as y. Same thing with cosine. Cosine is x over r. Since r is 1, cosine is the same thing as x. And then finally, tangent. Tangent's the tough one, especially when y and x are different. Tangent of 60 is the opposite side divided by the adjacent side, or you can say y divided by x. To divide a fraction by a fraction, we multiply the top fraction by the reciprocal of the bottom. So the tangent of 60 is equivalent to the square root of 3. All right, so on the unit circle, this means the x-coordinate is equivalent to the cosine ratio. And likewise, the y-coordinate is equivalent to the sine ratio. And one way I use to remember that is x comes before y in the alphabet, and c comes before s in the alphabet, so you don't get those mixed up. And then finally, tangent is equivalent to the y-coordinate divided by the x-coordinate, or another way to think about it is, since y is the same thing as sine, it's equivalent to sine divided by cosine.